Hey, what's going on? This is Wendell with Work From Home Tech. In this video, we have a lot of automation that's going to be going on. We're going to install Ubuntu. We're going to install Ollama. We're going to install the Llama 3 models, as well as an additional model to help you with Visual Studio Code. We'll install the CUDA toolkit to accelerate your AI experience. We'll install a proxy to secure the endpoint, and then we'll also install OpenWEBUI so you can have your ChatGPT experience. The best part of all is I'm going to show you and give you all the scripts to do it. So first and foremost, we're going to go ahead and take a look at the GitHub repository. Over on GitHub, we've got the Work at Home Tech repository. We have a repository that is called the Llama 3 deploy. And inside of here, you'll find all the scripts. What I've done is I've included all the scripts, and down in the description, hopefully once this video is done, I'll be able to update this with a better video rather than the Metal as a Service video. Oh, personal note there, the Metal as a Service will be utilized in this video. So if you haven't had a chance to take a look at that, go ahead and take a look at that one. The link will be in the comments below. But the file list under files describes the app update YAML file for updating your packages on Ubuntu. All of the installs here will be performed on Ubuntu 22.04. The CUDA install is going to install the CUDA Kit 12.4 version so you can accelerate the Ollama experience. The Docker install is going to pull straight from Docker and install the Docker Community Edition instead of the packages that are built in. We've got an inventory, which that's just basically for you to update as needed, depending on your IP addresses of your host or your host names. Standard license file, Llama CPP. Warning with this Llama CPP, that is a WIP or a work in progress. It's currently being worked on by myself to build the Llama CPP from source code for the mini PC Ryzen with the APU / built-in GPUs. I haven't gotten the final build options perfected so that it builds and is accelerated. It will build out of the box, but it's not going to be accelerated. It will run. It runs fairly decent. Next, we'll take a look at the Nginx proxy. This is just going to install the Nginx reverse proxy manager so you can provide SSH and actually SSL certificates so that you can access your endpoint via HTTPS. We have the Llama install, which is going to do from the site itself. It's going to do the Ollama install and install Ollama. It's going to install the Llama 3B model as well as an additional model that'll work with Visual Studio Code so you can do some development that's assisted by AI. And then the OpenWEBUI install is also included as part of that. So you'll be able to hit the website as soon as that script is completed, and you'll be able to have a ChatGPT type experience. Now that we're logged into the Metal as a Service, I want to go ahead and kick some machines off. So let's go ahead and we'll launch this guy right here. We're going to do some deployment on him. And this is going to install Ubuntu. This is going to be 22.04. We'll go ahead and install that. And we'll get that going. And then we're going to go ahead and take a look as that deploys. We'll take a look over here at Semaphore. One of the things I use to launch my Ansible scripts, let's turn on Docker mode real quick. My Ansible scripts will be launched by Semaphore. You can see here I've done some testing, and what I'll do is I'll go to my task template. These are some of the ones that I've specifically connected to this repository. So I have a task associated with each one of these files, and all it does is simply runs the Ansible playbook to run the script. So this is the folder I have with the playbooks. So with the Ansible command, which it's an easy install. If you can do an apt install Ansible, that'll install the Ansible utility. You can install it on Ubuntu. You can install it on Red Hat. You can install it on Mac. It may be a little more of a challenge installing it on Windows, but essentially it's Python based, so it can be utilized there. I tend to do most of my stuff for DevOps and deployments on a Unix based or Linux based. This is going to be what I use manually if I'm not using Semaphore. This is the Ansible playbook that executes these playbooks. Each one of those scripts in the repository is called a playbook. So what I do first here is I say user, and this is whatever your username is that will be remote accessing or secure shelling into the server that you're going to perform the playbook steps against. So Metal as a service, again, if you understand Metal as a service, it basically installs the cloud image of Ubuntu, which comes with a default Ubuntu user. So I specify the Ubuntu user, that user, and mass allows me to put secure shell keys or SSH keys when it's building or deploying onto the machine via Cloud Init feature. So those secure keys are there. I don't have to be so concerned because I've taken my keys from this machine. I put them in Metal as a Service. If you don't use Metal as a Service, you can do it manually with the simple SSH-copy command that'll copy them onto the machine. So again, simple one-liners to get basically the preparation steps for Semaphore accomplished for the command line. Not much different. All right, so continuing this command out, we've got Ansible playbook, we've got the user Ubuntu. We're going to do an inventory, and I have an inventory file that I just edited with all those IP addresses. But what I want to do is I want to limit that inventory file to 192.168.1, and I think it was 64 that I used. And I want to do just the apt update. Just something to show that I'm running this manually, and you can see it's going out and it's doing an Ansible playbook to basically update the packages. All right, so let's go ahead and switch back over to what we have. So this app update file is here. Basically what we're doing is we're going and we're adding some packages that I like to add when I'm running a server. I like tmux, I like curl, which is automatically there. In most cases, the Git's usually there. But I also add neofetch just to ensure that I can do a WTF on where I'm at when I go to a machine. So if you take a look, I can go over here and we'll do this. And I can kind of get information on, hey, what the heck's going on this machine? All right, enough said on that. So this is basically the script. And again, all these other scripts, that was the apt. Here's the CUDA install. One note about the scripts that I use. These are not canned scripts that I've put install packages in my repository, potentially introducing vulnerabilities. These are going directly out to the vendor sites. This is going straight to NVIDIA. The Llama install is going directly out to Ollama and do the install. So you can see here, I'm going HTTPS out to ollama.com to do the install. I'm not going ahead and creating my own packages or anything like that. So if you want to change that, you can. One thing to note, you might want to change just to not utilize so much traffic. If you want to come and download some of these models, some of the models in here that I'm downloading right here where I do the pull of DeepSeek for the coder. And then you can see here I'm pulling a Llama 3. These are multi-gigabit, almost 4 gigabits just for a Llama 3. So if you want to put that somewhere locally on your own machine, You are free to do that, but you're going to have to go inside of Llama and configure how to do that. All right, let's go back to check on our deployment. Now I have a repository I've set up, a local one I have, and then this is a straight from GitLab. That's what I use for testing. This one's Semaphore, and then this one is for production, where I present all the scripts out to the general public. Going back to task, we'll go ahead and get this Docker installed going. Let's go ahead and run that. So now we've got Docker installing. And it's updating Docker, going out to Docker, getting the key ring, and then it's going to install all the packages. So once it does that, I will go back to, let's just go ahead and go back now. So we'll leave that one running, but next what I want to do is I'll be installing these CUDA drivers. And what I did was I copied the CUDA driver file over from my test Git repository over to the production, but I haven't run them yet because I only have one machine that actually has, we'll take a look at it. I only have one machine, this work from home tech right here. Actually, that is actually the correct one. So we're going to do it on two. Let's go ahead and take a look at this one. See this one here? If we take a look at PCI devices, I have an old crypto mining GPU card 1070 in there. So what I want to do is I want to go ahead and go back to Ansible. And what I want to do is let's go ahead and we're going to modify this apt. Let's make sure our IP address is correct for this guy. So the one with the GPU is .71, 192.168.71. And we're going to go here and we're going to make sure this GPU file is not correct from the last time. So we're going to go and update that. So now we'll go back to task inventory. We'll go here, we'll edit this. And we will change this over to Ollama GPU. And then we'll go ahead and we'll hit run on this guy. So now that this guy is running over on our GPU machine, we'll let that go. And we'll go ahead and we'll update the Docker as well. We'll edit the Docker, get this guy to run on the GPU, and we will go ahead and let's take a look over on our site. I think I forgot. So yeah, this is one I've installed before. So it's complaining that I've already put the host keys, or sorry, the host entry in my known host. So it's asking me, hey, potential conflict. So we'll go ahead and do this again. So now we're in the Llama GPU. What I'll do is we'll just put an HTOP up there. All right. So you can see here, this guy's got a lot more CPUs. That should have been my clue.
Bruh.
But here we got the correct machine now. So what I'll do is I'll go back. All right, we're going to go back over here to the Llama Docker. Do we install that Docker? So let's go ahead and make sure Docker's up on this guy and running. So we'll do no Docker. So let's run Docker. Double check, make sure it's Llama 3. Yep. Run Docker, run. So now we've got Docker running over here, over in Semaphore. And then once that's done, we'll be able to just verify that Docker is available back over on the command line of our machine. What I'll do is we'll go ahead and close this, and we'll get the next guy ready to go. So there's Docker. Then we want the CUDA drivers. So let's go ahead and make sure the CUDA drivers are ready to go. We're going to change that to a Llama GPU. We'll save that. All right, and then we'll go. It looks like Docker's done. So we should be able to go back over to our command line, hit the up arrow, and now you can see Docker is on there. But notice, when I actually try to execute Docker commands, it's not running. The sockets aren't available because I probably need to manually start the services and get the socket going, or just reboot the machine. Now, I'm going to have to reboot the machine anyway once these CUDA drivers are run. So let's go ahead and start those guys off. So now the CUDA drivers are installing. So once the CUDA drivers are installed, we'll have to reboot the machine anyway to make sure that the CUDA drivers can access the GPU and everything works properly. So here we're pulling the kit, and we'll let those CUDA drivers install. We'll reboot, and then we'll install Ollama and all the associated models with Ollama. Now, the Llama install is going to take a little while longer, so I'll probably pause the video. All right, we're installed. We have installed the CUDA drivers, so now those are good. Now we're going to get ready to install Ollama. Change that to our GPU drivers, and we're going to go ahead and reboot the machine first. So once that guy comes back up, we'll go ahead and we will go ahead and let that ping while we're waiting for it to come back up. All right, looks like I'm pinging a little bit here, so ping's good. All right, so we'll launch our script here in a minute. I want to make sure it's actually up. Let's go ahead and secure shell into it. All right, we're going to secure shell into it. We're good there, so let's go ahead and go back and launch our script. All right, once this goes through, we'll be back when it finishes. So we've got the models. It's getting the final web UI and installing that Docker Compose. We're almost done. As you can see here, we pull the model, we pull the DeepSeek. We added a crew AI model file, and web UI is there, containers there, and we're starting the actual container with a Docker Compose file. Now that container is going to be running on port 4000. If you take a look at the Ollama install and you're interested in changing that, you can do that right here. You can see port. It runs by default in the container on 8080. I've changed it to 4000. So you can take a look and change that if you want. And we're just waiting for that to go, and it looks like it's done. So now that that's done, this should be ready to go. So what we're going to do is we're going to go over to HTTP 192.168.1.71, 1.71, and it's port 4000. And there we are. We have our web UI. So what we'll do is we'll go ahead and sign up. We'll say tech at, just making this up, and I put it in the wrong slot. And we'll create this guy. Say never, and there we go. Let's go. So we should be able to come here and we should see the models we installed. There we go. There's the Crew AI, there's a DeepSeek, and then there's the Llama 3 latest. 8B. Let's also go in here and we want to change this sucker to a dark theme. All right. So what we'll do is I want to take a real quick look over. What we're looking for is we're looking to make sure that we have searching for GPU management libraries, discover GPU libraries, NVIDIA GPU Tected. So we wanted to make sure that CUDA is in fact loaded. So now we'll go back and we can go ahead and do tell me a fun fact, and we can get our response from the Ollama model that we're querying. And here we go. It's giving me my fun fact. Let's ask it. Why is the sky blue? And you can see this is responding with a older NVIDIA 1070 card. So this is pretty cool. I also wanted to go and show you one more thing. If we go back over to the Linux machine, if you load up this Code GPT chat, this will allow you to interface with the DeepSet model that we loaded that's included in the script. One of the things that I did have to do was I need to do some more research on this because it looks on the local machine to ensure you have it installed locally. To make it work remote, I had to actually use a secure shell tunnel. If you're trying to do that, you're having problems with that, just shoot me a comment and I can give you the little one-line script for that if I don't remember to put it in the comments below. But other than that, that's it for this video. I know it was a lot. I know it was complex, but this is going to give you the repeatability to build, destroy, and do CRUD operations and test things out iteratively with ease. This is kind of agnostic where it's not specific to an AWS. If you can get a VM in AWS as a GPU, you can do this. If you get it in Azure, you can do this. If you have it on Google, you can do this. If you have it on bare metal, co-hosted, you can still do this. So shoot comments, questions, anything you need. If you actually would like to sign up for the newsletter, don't forget the tech site. Go ahead and take a look over at the tech site. We've got hardware over here that we're doing reviews on, pretty good reviews. If you're looking to get more information, hit the subscribe button if you haven't already, and stay tuned for more videos. Peace.